Hello guys, my name is Sushanth. I'm a fourth year undergrad from the Department of Computer Science at IIT Kharagpur. I am from Visakhapatnam, Andhra Pradesh. I passed my JEE in the year 2020. I have secured 230th rank in JEE mains and 1036 in advanced. I feel like I have a very good grip in physics. So I would like to share my knowledge with you. And coming to the today's topic, today we are going to speak about laws of motion, which are which define everything in physics. సో ఇంకా ముందుకెళ్తే ఈ ఈ లాస్ ఆఫ్ మోషన్ అనే చాప్టర్ లో ఏం చదువుతామంటే ఫస్ట్ మన బేసిక్ ఒక కదులుతున్న ఆబ్జెక్ట్ ని అది ఎలా కదులుతుంది అని కొన్ని రూల్స్ గవర్న్ చేస్తాయి. ఆ రూల్స్ ని న్యూటన్ తన 3 లాస్ ఆఫ్ మోషన్ లో మనకి ఇచ్చారు. న్యూటన్ కన్నా ముందు మనకు ఫస్ట్ ఒక అరిస్టాటిల్ ఒకలా అనుకున్నారు. ఏంటి అంటే ఒక ఆబ్జెక్ట్ కదులుతూ ఉండాలి అంటే దానిపైన ఏదో ఒక ఎక్స్టర్నల్ ఫోర్స్ పడుతూనే ఉండాలి అని అరిస్టాటిల్ అన్నాడు. కాకపోతే ఇది ప్రతిసారి ఇలా అవ్వాల్సిన అవసరం లేదు అని గెలీలియో ఒక అబ్జెక్షన్ తో ప్రూవ్ చేయడానికి ట్రై చేశాడు. అది ఎలా అంటే ఒక ఫ్రిక్షన్లెస్ సర్ఫేస్ పైన ఒక ఆబ్జెక్ట్ ని రోల్ చేసి వదిలేస్తే అది మనం ఆపాలి అనుకున్నంత వరకు అది ఆగదు. అంటే ఇక్కడ ఏం ఫోర్స్ లేకుండానే బాడీ కంటిన్యూస్ గా కదులుతూనే ఉంది. విచ్ ట్రైస్ టు ప్రూవ్ దట్ అరిస్టాటిల్స్ పాయింట్ ఆఫ్ సేయింగ్ an external force is required is wrong. అండ్ దీనిపైన యాడ్ చేయడానికి ఇంకా గెలీలియో కొన్ని రూల్స్ లాగా డిఫైన్ చేశాడు. దాన్ని ఫస్ట్ కొన్ని ఎగ్జాంపుల్స్ తో చెప్పాడు. అంటే ఫస్ట్ ఈ ఎగ్జాంపుల్ తీసుకుంటే ఒక ఇంక్లైన్ ప్లేన్ పై నుండి ఒక బాల్ ని వదిలేస్తే దాన్ని మనం ఏం ఫోర్స్ ఇవ్వకుండానే అది కిందకు వస్తుంది. దట్ విత్ అన్ యాక్సలరేషన్. ఈ యాక్సలరేషన్ చెప్పడానికి తన మీనింగ్ కిందకు వస్తున్న కొద్దీ తన వెలాసిటీ పెరుగుతుంది అని. అదే దాన్ని ఒక ఇంక్లైన్ ప్లేన్ పైనకి ప్రొజెక్ట్ చేస్తే వెలాసిటీ తగ్గుతుంది అని. ఇంకో ఎక్స్పెరిమెంట్ ఏంటంటే ఇదే దాన్ని ఒక ఫ్లాట్ సర్ఫేస్ పైన చేశాడు. ఒక చిన్న పుష్ ఇచ్చి వదిలేస్తే ఆ ఆబ్జెక్ట్ ఎప్పటికీ ఆగట్లేదు. సో దీన్ని బట్టి తను ఏం చెప్పాలి అనుకున్నాడు అంటే unless we provide some external force, the state of motion of an object remains same. ఇది తను చెప్పాలనుకుంది. ఇది ప్రూవ్ చేయడానికి ఇంకా చాలా ఎక్స్పెరిమెంట్స్ చేశాడు తను. బట్ దెన్ ఇది చాలా బేసిక్ గా ఉంది. దేర్ ఈస్ నథింగ్ మ్యాథమెటికల్ ఇన్ దిస్. దట్స్ వెన్ న్యూటన్ కేమ్ ఇన్ టు ద పిక్చర్. అండ్ బేసిక్ గా ఇందాక మాట్లాడుకున్నట్టు గెలీలియో చెప్పింది ఇదే. ఎవ్రీ బాడీ కంటిన్యూస్ టు బి ఇన్ ఇట్స్ స్టేట్ ఆఫ్ రెస్ట్ ఆర్ యూనిఫామ్ మోషన్ ఇన్ ఎ స్ట్రైట్ లైన్ అన్లెస్ కంపెల్డ్ బై సమ్ ఎక్స్టర్నల్ ఫోర్స్. అరిస్టాటిల్ చెప్పాలనుకుంది ఇది. దీన్ని న్యూటన్ మ్యాథమెటికల్ గా చెప్పాడు. అది న్యూటన్ ఫస్ట్ లా ఆఫ్ మోషన్. ఇఫ్ ద నెక్స్ట్ న్యూటన్ ఫస్ట్ లా ఆఫ్ మోషన్ మాట్లాడే ముందు మనం ఇనర్షియా గురించి డిస్కస్ చేయాలి. ఇనర్షియా అంటే ఏంటంటే ద inert or let's say present state of motion of an object. ఇది inertia of an inertia అంటే the present state of motion of an object. ఇంకా దీని ఏమన్నాడు అంటే ఒక ఆబ్జెక్ట్ రెస్ట్ లో ఉంటే అది ఎప్పటికీ రెస్ట్ లోనే ఉంటుంది అన్లెస్ దేర్ ఇస్ సమ్ ఎక్స్టర్నల్ ఫోర్స్ యాక్టింగ్ ఆన్. నువ్వు దాన్ని ఏదైనా పుష్ చేయడానికి ట్రై చేస్తే తప్ప అది దాని స్టేట్ ఆఫ్ మోషన్ మార్చుకోదు. ఫస్ట్ దీన్ని ఇలా కూడా చెప్పాడు. సపోజ్ ఒక ఆబ్జెక్ట్ ఇటువైపు కదులుతుంది సమ్ వెలాసిటీ వీతో, దాన్ని నువ్వు ఏం చేయకపోతే అది ఎప్పటికీ ఇంకా ఈ డైరెక్షన్ లో కదులుతూ ఉంటుంది. కాకపోతే ఏదైనా ఒక ఫోర్స్ అప్లై చేసి దాన్ని నువ్వు ఆపేయాలని ట్రై చేసినప్పుడు ఇటు నుంచి దీని వెలాసిటీ 0 అయిపోద్ది. ఒక మోషన్ లో ఉన్న ఆబ్జెక్ట్ రెస్ట్ లోకి వెళ్ళిపోతుంది. ఇక్కడ రెస్ట్ లో ఉన్న ఆబ్జెక్ట్ మోషన్ లోకి వెళ్తుంది. సో ఒక ఆబ్జెక్ట్ తాలూకా ఇనర్షియల్ స్టేట్ ని ఆబ్జెక్ట్ తాలూకా ఇనర్షియల్ స్టేట్ చేంజెస్ ఓన్లీ ఆన్ అప్లికేషన్ ఆఫ్ అన్ ఎక్స్టర్నల్ ఫోర్స్. అంటే ఏంటి అంటే మనం ఒక ఎక్స్టర్నల్ ఫోర్స్ ఆబ్జెక్ట్ పైన యాక్ట్ చేస్తే గానీ దాని ఇన్నర్ట్ స్టేట్ ఆఫ్ మోషన్ ఎప్పటికీ మారదు. దాన్నే తన న్యూటన్స్ ఫస్ట్ లా ఆఫ్ మోషన్ గా మనకి ఇచ్చాడు. ఇఫ్ ద నెట్ ఎక్స్టర్నల్ ఫోర్స్ ఆన్ బాడీ ఈజ్ జీరో, సో దర్ ఇస్ నో ఎక్స్టర్నల్ ఫోర్స్ యాక్టింగ్ ఆన్ ద ఆబ్జెక్ట్, యాక్సిలరేషన్ కెన్ బి నాన్ జీరో ఇఫ్ అండ్ ఓన్లీ okay, if the net external force on the body is zero, the acceleration is zero. In the sense that ఒక మోషన్ లో ఉన్న ఆబ్జెక్ట్ ఎప్పటికీ మోషన్ లోనే ఉంటుంది, లైక్ యూనిఫామ్ వెలాసిటీతో. ఒకవేళ రెస్ట్ లో ఉంటే రెస్ట్ లోనే ఉంటుంది. దాన్ని నెగేషన్ గా ఇంకోసారి మాట్లాడాలి అంటే యాక్సిలరేషన్ కెన్ బి నాన్ జీరో ఇఫ్ అండ్ ఓన్లీ అండ్ ఎక్స్టర్నల్ ఫోర్స్ యాక్ట్స్ అని. ఒకవేళ ఏదైనా ఫోర్స్ యాక్ట్ అయితేనే ఆ బాడీకి యాక్సిలరేషన్ వస్తుంది. దిస్ ఇస్ వాట్ యూ వాస్ ట్రైయింగ్ టు సే. లైక్ ఈ రెండు స్టేట్మెంట్స్ అంటే యాక్సిలరేషన్ లో ఉండాలి అంటే ఏం చేయాలి, యాక్సిలరేషన్ జీరో ఉండాలి అంటే ఏం చేయాలి అని. సేమ్ ఇలానే ఇప్పుడు మనం ఒక ఆబ్జెక్ట్ ని స్టార్టింగ్ లో మోషన్ స్టార్ట్ చేయాలంటే ఏం చేయాలని ఆలోచించాం, ఉన్నదాన్ని ఆపేయాలి అంటే ఏం చేయాలని ఆలోచించాం. కానీ ఆల్రెడీ మోషన్ లో ఉన్న ఆబ్జెక్ట్ ని ఫోర్స్, దాని వెలాసిటీ పెంచాలి అంటే ఏం చేయాలి, ఆర్ ఎల్స్ ఫోర్స్ ని మ్యాథమెటికల్ గా ఒక న్యూమరికల్ గా ఎలా రిప్రజెంట్ చేయాలి అని ట్రై చేసినప్పుడు we talk about something called momentum. Momentum of a body is defined as the product of its mass and velocity. ఒక ఆబ్జెక్ట్ సమ్ మాస్ m అనుకున్నాం, ఇట్స్ మూవింగ్ విత్ వెలాసిటీ v. మొమెంటం ని మనం p అనే ఆల్ఫాబెట్ తో రిప్రజెంట్ చేస్తాం, స్మాల్ p తో. ఇట్ ఈస్ డిఫైన్డ్ as the mass into velocity of the object. అండ్ since mass ఇక్కడ scalar, ఇంకా velocity vector, which makes momentum also a vector. And Newton defined this momentum to be forces or else if you ఒకవేళ మనం మరి చిన్న ఇంటర్వల్స్ కోసం ట్రై చేస్తే, like if you're trying to define force in a very small interval, we then use this representation dp by dt. Or else if you're trying for a larger intervals, like relatively larger intervals, we try using delta p by delta t. So force is defined as rate of change of momentum. So ఇదే స్టేట్మెంట్ ని తను మ్యాథమెటికల్ గా రిప్రజెంట్ చేసి he gave it as a second law of motion, న్యూటన్స్ సెకండ్ లా ఆఫ్ మోషన్. ఓకే, సో దీని గురించి మనం ఒక జనరలైజ్ ఐడియా కోసం అర్థం. ఫస్ట్ ఒక ఆబ్జెక్ట్ సమ్ 5 kg ఆబ్జెక్ట్ ఉంది, ఇది సమ్ 2 m/s తో కదులుతుంది. ఇంకొక దగ్గర 10 kg ఆబ్జెక్ట్ ఉంది, 2 m/s తో కదులుతుంది. దీన్ని మనం స్పీడ్ పెంచాలనుకున్నాం 3 m/s కి, దీనికి కూడా మనం స్పీడ్ పెంచాలి అనుకున్నాం 3 m/s కి. ఎక్కడ మనకి ఎక్కువ ఫోర్స్ అప్లై చేయాల్సిన అవసరం పడుతుంది, where there is more mass you need to push it with a harder force, like a greater force should be applied to make the same change. సో ఒక 10 kg ఆబ్జెక్ట్ ని మూవ్ చేయడానికి మనకి ఎక్కువ ఫోర్స్ అవసరం అవుతుంది. సో ఫోర్స్ ఈజ్ డైరెక్ట్లీ ప్రపోర్షనల్ టు మాస్. ఇది మనం ఎంప్లాయ్ చేయొచ్చు. ఇదే దానికి సపోజ్ ఇదే 5 kg ఆబ్జెక్ట్ ని 3 m/s కాకుండా లెట్స్ సే వి వాంట్ టు మూవ్ ఇట్ టు 5 m/s. సో స్పీడ్ చేంజింగ్ చాలా అంటే ఎక్కువగా చేంజ్ చేయాల్సి వస్తుంది. సో ఫోర్స్ ఈజ్ ఆల్సో ప్రపోర్షనల్ టు ద చేంజ్ ఇన్ వెలాసిటీ వి గివ్. బట్ ఈ చేంజ్ ఇన్ వెలాసిటీని మనం ఎంత ఫాస్ట్ గా ఇవ్వాలి అనుకుంటున్నాం అది కూడా మ్యాటర్ అవుతుంది. ఎందుకంటే ఇదే 2 m/s ని నువ్వు 0.1 సెకండ్ లో తీసుకురావాలనుకుంటున్నావు, ఇంకోసారి 1 second లో తీసుకురావాలనుకుంటున్నావు. ఆ 1 second టైంలో నీకు చాలా తక్కువ ఫోర్స్ పెట్టాల్సిన అవసరం వస్తుంది. సో ఇట్ ఈస్ ఇండైరెక్ట్లీ ప్రపోర్షనల్ టు టైం, which makes it acceleration. So Newton's second law is basically giving us this mathematical representation of force, that force is equal to mass into acceleration. This force can be in many ways, like it could be in a circular motion, it could be in a linear motion. This is an example with linear motion. But when we talk about circular motion, let's consider this case. An object is moving in a circle in figure 5.4. Let's say an object is moving in a circle, but it's not dropping down, even though there's gravity here. So, actually, the basic intuition would be the ball would fall down, but the ball is not falling down. It's continuing its state of motion in this direction. But let's okay, the state of motion. We think the state of motion is we think that here the state of the motion of an object is in a circle. The speed is the same, but the velocity vector is changing. So from the first law, what did we learn? We learned that whenever an object changes its momentum, we need to apply some force, or else the change of state of a motion is always governed by the force acting on it. సో ఇలా అనుకుంటే ఇప్పుడు దీని వెలాసిటీ ఫస్ట్ ఈ డైరెక్షన్ లో ఉంది, ఇక్కడికి వచ్చేసరికి ఈ డైరెక్షన్ లోకి మారింది. సో దర్ ఇస్ చేంజ్ ఇన్ డైరెక్షన్ ఆఫ్ వెలాసిటీ. వెలాసిటీ బీయింగ్ ఎ వెక్టర్, dv bar ఇప్పుడు జీరో కాదు, బట్ ఇఫ్ యూ టాక్ అబౌట్ స్పీడ్ it might be zero because speed is just the magnitude. And because of velocity being a vector, there will surely be an acceleration. And so we for sure require a force to maintain the body in its circular motion. But in what direction? Okay, let's see. So the velocity here is in this direction. Let's talk some simple terms. Here, the velocity here is in this direction, v bar, and here it is in this direction. So if I want to change this instantaneously, what did I say? Force equal to m of v1 bar minus v2 bar by time. So the we know vector subtraction, right? This is v1, this is v2, v1 minus v2, so something like this, minus v2, so something like this. So force will, for this entire region of the circle, for the velocity to change from this direction to this direction, we need to apply a force which is this parallel to this. So there is some force in this direction. Okay. From this direction. So we always govern a force by this equation. And acceleration being a vector, force is also a vector. Force equal to mass into acceleration. This is the second law of motion. And ఒకవేళ మనం వర్డ్స్ లో చెప్పాలి అనుకుంటే, the rate of change of momentum is directly proportional to the applied force and takes place in the direction of the force acts. That means if we apply a force of 5 newtons in this direction, and the unit of force is newton, which it is a fact. The change of momentum is directly proportional to the applied force. Let's say in this case we applied a 5 Newton force. In the other case, we applied a 10 Newton force. So the rate of change of momentum, we got to know that force is directly proportional to the rate of change of momentum. So higher the force, higher the change in momentum. So in this case, the change of momentum will be less than in this case. So this case, more change. So we got the proportionalities, and then we replace the proportionality with some constant, and we write this like this. And then upon some experimental conditions, we got to know that this value is 1. So force is directly given as dp by dt or delta p by delta t. Okay, for a fixed mass object, since we know momentum to be mass into velocity, for a fixed mass object, dp by dt is d by dt into m, d by dt of m cross v. M is a constant, so we'll take it out. M into dv by dt, that is mass into acceleration. Which okay, this is force. This దీని బట్టి మనకి ఏం తెలుస్తుంది? Force is directly proportional to acceleration. So second law can also be written as force equal to k into mass into acceleration, and we got the k to be 1. The SI unit of force is Newton, which is named after the scientist who gave all these rules. Newton is 1 kg meter per second square. Why is it kg meter per second square? Because force equal to mass into acceleration. Mass is kg. Acceleration is the rate of change of velocity. So meter per second kg meter per second square. So this is the SI unit of force, and 1 unit of kg meter per second square is named after the scientist Newton. So 1 Newton is 1 kg meter per second square. And there are some certain limitations to this second law of motion, that the frame of reference. What is the frame of reference? Let's say you're watching a ball. Let's talk about this example. A woman is watching the ball fall from some certain height outside the train. Or there is one more woman who is watching this from outside of the train. She sees the ball falling in a vertically downward direction. But for her, since her train is moving with some velocity v, she sees the object moving backwards. So for a ball moving down, let's say she's watching from this point, and there's another guy watching from this point. Frame of reference is like from where we are observing the motion of an object. So for an observer on the ground, the ball will be falling vertically downwards. But for an observer on the train, since he has a velocity in this direction, and he thinks he is in rest and everything is moving backwards. Because this is the concept of frame of reference, that you feel that you are the center and everything is moving around you. So he will think that the ball is moving backwards with a velocity v. He thinks the ball is moving like this. And for the observer on the ground, the ball will be falling like this. So yeah. So while writing the force equation, force equal to mass into acceleration, the acceleration being a vector, it depends on the frame of reference. Like if you're in an accelerating frame of reference, okay, let's talk about frame of references. Frame of reference. Frame of reference is basically the point or location and where we are observing the motion of an object. Okay. And depending on the frame of reference we choose, every vector quantity will change. Let's say someone is in this frame and it is moving with an acceleration of 1 meter per second square. And there's a ball on this ground, which is at rest. And there's another guy who is moving in this direction with 2 meter per second square. And there's one third guy. He's the first one, second one, and here is the third guy. So the first guy, he feels that he is the center and he feels that everything around him is moving backwards with an acceleration of 1 meter per second square. So the first one sees the ball moving backwards with 1 meter per second square. So acceleration of the ball with respect to 1 is minus 1 meter per second square. And similarly, for the second guy, his acceleration is 0. So he feels that whatever he sees is the absolute accelerations of everything. Acceleration of b with respect to 2 is 0. And similarly, in case of third man, he is accelerating in the left direction with 2 meter per second square, and the ball is at rest. And he thinks he is the center, so he feels that the ball is moving in the right side with 2 meter per second square. Yeah. So the same ball is having 3 accelerations in 3 different frames of references, and force is directly proportional to acceleration. But which acceleration? So to solve this problem, we got two types of frames. We have 2 types of frames. First one is an inertial frame of reference. Second one is a non-inertial frame of reference. So inertial frame of reference are like the standard ones, where the acceleration of the frame is 0. Acceleration of the frame is 0. And these are the ones where the Newton's laws of motion we discussed till now can be applied without any changes. Like force is directly proportional to mass into acceleration. Force can be defined as rate of change of momentum. And yeah, the third, okay, this one. And the non-inertial frame of references. The non-inertial frame of references are something that have an non-zero acceleration. Acceleration of frame is not 0. సో ద ఫోర్స్ కెనాట్ ద ఫోర్స్ దట్ ఆ ఫోర్స్ ఈక్వేషన్ మనం డైరెక్ట్ గా ఇలా ఎఫ్ ఇంటూ ఎంఏ అని వేసేయలేం. దాని బదులు వీ నీడ్ టు చేంజ్ ద యాక్సలరేషన్ వెక్టర్. లెట్స్ సే ద యాక్సలరేషన్ విత్ రెస్పెక్ట్ టు ద ఫ్రేమ్ ఇస్ acceleration with respect to the frame is some a bar, and acceleration of the frame is some af bar. So for the frame, the force equation to be valid, we put this acceleration with respect to f bar plus acceleration of f bar. This slight change must be made in the force equation to make the force valid. Or so ఎలా ఉంటుంది. But let's say there is a third law of motion. Suppose there is an object. The third law of motion states that to every action there is an equal and opposite reaction. అంటే నువ్వు దేన్నైనా ఒక ఆబ్జెక్ట్ ని 5 న్యూటన్ ఫోర్స్ తో పుష్ చేస్తే ఆ ఆబ్జెక్ట్ నిన్ను 5 న్యూటన్ ఫోర్స్ తో పుష్ చేస్తుంది. This can be generalized everywhere. Like, let's say your weight is 50 kgs. The implication of 50 kg is that earth pulls you with a force that is equivalent to 50 kgs, and you also pull the earth with the same force. And there is an object that's laying on the ground, and its weight is some mg. So on the floor there will be a force of mg. So the force tries to react to this. This is the action. So the floor gives a force on you which is normal. Like for any two objects in contact, there will be some contact forces. That is called a normal force. And since only two objects are in contact and the force is mutual between them, from the Newton's third law, we say that if this is n, this is also n. And there are some rules for the action-reaction phase. Action and reaction can never act on the same object. First rule: action and reaction can never act on the same object. This one: action and reaction never act on the same object. And the action-reaction phase are always opposite in direction and equal in magnitude. Let's say this is the action. This is they won't act on the same object. And let's say this is the reaction. Action and reaction. So magnitude-wise, the force of action is equal to the force of reaction, and force of action is equal and opposite in direction. This one. These are the three laws of motion which govern the motion of an object. Let's see an example on this. If we combine, let's see an example on combining all these three law of motions. In the first, let's read the question. Two identical billboard balls strike a rigid wall with the same speed but at different angles and get reflected without any change in speed. Speed is not changing, but the direction is getting changed. And we know our momentum to be a vector. P bar equal to mv bar. What is the direction of the force of wall due to each ball, and the ratio of magnitudes of impulses imparted to them? Okay, and what is impulse? Impulse is defined as the rate of change the change in momentum. Impulse on any object is the change in momentum at that point on that object. First one, the direction of the force on the wall due to each ball. In this case, the ball is going in this direction u with a velocity u, and it came back with a same speed but change in directions. So what is the change in momentum? M of initially P equal to M of V final minus V initial. V final, let's take this direction to be positive, minus u minus of u. So minus 2mu. This is the change in momentum. And what is the direction of force? For an object moving in this direction, if it is getting changed to this direction, it is an intuition that some force must be applied in this direction that nullifies this velocity and gives it an extra velocity in this direction. So the direction of force is obvious, since so the force must have a component in this direction. Only we can say about the component of force. కానీ ఒకవేళ ఇప్పుడు ఇది ఇటు నుంచి ఇటు వచ్చింది, అండ్ we know that force is dp by dt or mostly delta p by delta t, which indicates that force has the same direction as change in momentum. Since time is a scalar, force has the same direction as change in momentum. So initially it is moving with the momentum of mv in this direction, and it got changed to mv in this direction. So the change in momentum is minus 2mu, and we took this direction as positive. So force will have the same direction, this direction, same as the direction of change in momentum, which gives us this. The direction of forces in this case is this one. Let's talk about this. Initially, you have a momentum mu in this direction, and then after this, you have mu in this direction. So what is the change in momentum? Momentum is a vector. Split it into components. 30. So this will also, from the parallel lines, this will also be 30. This is 30, making this is also 30. So this is mu sine 30, mu sine 30. So horizontal component is mu cos 30 degrees. The vertical before the collision, it has mu cos 30. After and here mu sine 30. After the collision, it has mu cos 30 in this direction and mu sine 30 in this direction. In the vertical direction, there is no change in momentum. So there is no force acting in this direction. Since change in momentum is 0, the force in the direction is 0. Okay, the only change in momentum is in x direction. So the force must be along x-axis. Since we got to know that the direction of force and the direction of change in momentum will be the same. So mu sine, okay, mu cos 30 in this direction change to mu cos 30 in this direction. So it will be m minus u cos 30 minus u cos 30, which is minus 2mu cos 30. Change in momentum in this direction. So again, the force will be in this direction. Force is again in the same direction. Okay, and what did he ask? The ratio of magnitude of impulses. Impulse, as we defined, is the change in momentum. The ratio of impulses is simply 2mu by 2mu cos 30. 2mu to mu cancels out. 1 by cos 30, which is okay, 1 by root 3 by 2, 2 by root 3, 2 by root 3. This is the way we solve such problems. And there is this law of conservation of momentum that states that upon a system, if the net force is 0, this implies that dp by dt is 0, which implies that p is a constant. So if a system has net force acting on it as 0, the momentum of the system remains constant. The momentum of the system remains constant. So there are many vivid applications of this. దీనికి చాలా అప్లికేషన్స్ ఉంటాయి. అండ్ in an isolated system, అంటే isolated system అంటే net force acting on the system is 0, or else there is no external force acting on it. Both come under the isolated system concepts. Okay, equilibrium of a particle. Equilibrium of a particle in mechanics refers to the situation where the net external force of the particle is 0. Okay, whenever an object is in equilibrium, the net force acting on an object is 0. And let's see this with an example. Here, an object is hung using a string in this direction. There are 2 threads attached here, and the force of okay, we are pulling a mass of 6 kg is suspended by a rope of length 2 meters from the ceiling. A force of 15 newtons in the horizontal direction is applied at the midpoint of the rope. What is the angle that the rope makes with the vertical and equilibrium? So initially it's like this, and here we apply a 15 Newton force. So it gets hung up in some point like this, 15 newtons. This side it will be T1. Let's say T2. And let's draw the free body diagram of the body. Free body diagram of the body, this is mg, and this is T2. So for this object to be in equilibrium, the net force acting on this should be 0. T2 equal to mg. We can conclude this. And here, at this point, let's say the angle with the vertical is theta. This is theta. Then T1 cos theta should be equal to T2 for the system to be equilibrium. Net forces at any point should be 0. And then T1 sin theta equal to 15 newtons. When we divide these two, we'll get sin theta by cos theta, which is equal to tan theta, is equal to 15 newtons by T2. T2, which is mg. Mass is 6 kgs and g is 10. G is 10, which makes our tan theta 5 by 6. Tan theta is 5 by 6. This is how we solve some problems in the concept of equilibrium. And forces are there are 2 types of forces. The force which is observed from an inertial frame of reference is called a real force, and the force or the magnitude of forces which we observe from a non-inertial frame of reference or an accelerating frame of reference is called a pseudo force. You might think that why do we need this pseudo force? We can always try to solve problems in the normal frame of references, but then when we talk about circular motion, we'll get to know that sometimes solving problems in accelerated frame of reference makes our life easier. Okay, and there are different types of force. Like if there is a rope connected, there is a tension force here. And if we are connected to a spring, there will be spring force, or we can also call it as elastic force. And then you might have experienced this. When you try to push an object into the water, we face some resistance. That is because of the buoyancy. So a buoyant force, or else when we try to rotate something, we again let's say inside water, we again face a resistance. But this time it's not just buoyancy. Sometimes it can be viscous force, which is a friction force inside water or any fluid. Okay, friction. What is friction? Let's come to the Galileo's point again. What did he say? On a smooth surface, when we gave a velocity v to an object, it never stopped. And he mentioned the word smooth. Why did he mention this? That means there should be something going on unexpected on a rough surface. Let's say there's a rough surface and he gave a velocity v. Like with basic intuition, we can say that the ball doesn't go up to a very long distance. It stops after going, let's say, here. So there is some force acting on the object that's changing its state of motion from a velocity v to velocity 0 across this distance. But in the case of smooth surface, there's nothing going on. And the force which is responsible for this is called friction. Friction is friction is generally caused because of this small irregularities at the surface. No surface is 100% smooth. And let's say an object is like this. And మనం ఎప్పుడైతే ఈ ఆబ్జెక్ట్ ని దీనిపైన పెట్టాలనుకుంటామో there might be something like surface ఇలా ఉంది and the object is like this. So when we try to slide the object over the surface, it will obviously face some resistance. Like ఆ ఇంటర్లాకింగ్స్ వల్ల అది ముందుకు వెళ్ళేటప్పటికి దానిపైన ఒక ఫోర్స్ ఉంటుంది కదా, ఇక్కడ కానీ ఇలా కానీ, లెట్స్ సే ఇలా ఒకటి ఉంది, ఇంటర్లాకింగ్ ఇలా అయింది. కానీ ట్రై టు పుల్ ఇట్ ఇన్ దిస్ డైరెక్షన్, అది ఇక్కడ ఆపేస్తుంది నేను ఇక్కడ ఈ కొలిజన్ వల్ల, విచ్ ఇస్ క్రియేటింగ్ సమ్ ఫోర్స్. Basically, friction is generated because of this interlockings. There are many theories why friction is generated between two surfaces. The one that is simple to understand is this interlocking thing. That is why, like, if we because of these interlockings, we know that friction causes wear and tear. And to అదే ఫ్రిక్షన్ ని సమ్ మ్యాథమెటికల్ టర్మ్స్ లో మాట్లాడేలా అంటే మనం మెజర్ చేయగలగాలి ఫ్రిక్షన్ ఎంత వస్తుంది మ్యాక్సిమం అని. ఒక ఫ్రిక్షన్, లెట్స్ టాక్ అబౌట్ దిస్ ఏ గ్రాఫ్. మనం ఒక ఎక్స్పెరిమెంట్ చేద్దాం. ఒక ఆబ్జెక్ట్ ని ఒక సర్ఫేస్ పైన ఉంది, దాన్ని 0 నుంచి 1 న్యూటన్ 2 న్యూటన్స్ 3 న్యూటన్స్ అలా పుష్ చేయడానికి ట్రై చేసాం. దాని యాక్సలరేషన్ ని ప్లాట్ చేయడానికి ట్రై చేద్దాం. అప్పుడు ఇలాంటి ఎక్స్పెరిమెంట్స్ చేయడం వల్ల మనకు వచ్చిన రిజల్ట్స్ ఏంటి అంటే, అప్ టు ఏ సర్టెన్ పాయింట్ దాని యాక్సలరేషన్ ఎప్పుడు 0 ఉంటుంది. ఒకవేళ ఫోర్స్ 5 న్యూటన్స్ దాటి ఏమైనా అప్లై చేస్తే దెన్ ద ఆబ్జెక్ట్ స్టార్టెడ్ మూవింగ్ అండ్ దెన్ ద యాక్సలరేషన్ వెంట్ లైక్ దిస్ సడన్లీ. సో up to a certain point the acceleration is 0 and from there it went like this. So continuous, మనం ఇలా కాకుండా డిస్క్రీట్ గా 0 1 2 3 ఇలా అనుకోవడం కాకుండా కంటిన్యూస్ గా ఇస్తే ఫోర్స్ వర్సెస్ యాక్సలరేషన్ గ్రాఫ్ ఇలా ఉంది. సో అంటే ఈ ఫోర్స్ వరకు మనకు ఆబ్జెక్ట్ లో ఏ మోషన్ లేదు. why is it happening? Because of this friction force. Friction exists between any two surfaces in contact. The amount of friction that exists is defined or like you can say you can numericalize by using this coefficient called coefficient of friction. ఈ coefficient of friction లో మళ్ళీ 3 types ఉంటాయి. Static friction, sliding friction, and then rolling, which is not like it won't, మీరు చాలా తక్కువ చూస్తారు దీన్ని, but then it still exists. Static friction is when the object is at rest on a surface. Sliding friction is when an object is moving on a surface. And ఇప్పుడు మీకు తెలుస్తూనే ఉంటుంది, ఒకవేళ 2 కోఎఫిషియెంట్స్ తీస్తే స్టాటిక్ అప్పటికి స్లైడింగ్ అప్పటికి mu static is always greater or equal to mu sliding. This can be made obvious. Like కొంచెం ఆలోచిస్తే మీకే కరెక్ట్ అనిపిస్తుంది. ఎందుకంటే ఒక ఆబ్జెక్ట్ రెస్ట్ లో ఉంది, దాన్ని మూవ్ చేయడానికి ట్రై చేసాం. వీఆర్ ట్రైంగ్ టు చేంజ్ ద స్టేట్ ఆఫ్ మోషన్. అప్పుడు మనకి ఆబ్వియస్ గా ఎక్కువ ఫోర్స్ అప్లై చేయాల్సి వస్తుంది. సో అండ్ ఫ్రిక్షన్ ఈస్ గివెన్ బై దిస్ థింగ్. Let's say because of this mass, we have a reaction force on the ground that is a normal force. Friction is mathematicalized using the coefficient of friction in this format: mu into the normal force. ఈ స్లైడింగ్ ఫ్రిక్షన్ కి ఇంకో పేరు కైనెటిక్ ఫ్రిక్షన్. దీన్ని ఇక్కడ అప్పుడప్పుడు దీన్ని మ్యూ స్టాటిక్ ని అప్పుడప్పుడు మ్యూఎస్ అని ఎలా రిప్రజెంట్ చేస్తాం, మ్యూ కైనెటిక్ ని మ్యూ కే అని రిప్రజెంట్ చేస్తాం. And coming to the topic, ఒక ఆబ్జెక్ట్ రెస్ట్ లో ఉంది, దాన్ని మనం పుష్ చేయాలని ట్రై చేస్తాం, విచ్ ఇస్ వీఆర్ ట్రైంగ్ టు చేంజ్ ఇట్ స్టేట్ ఆఫ్ మోషన్. అప్పుడు మనకి ఒక గ్రేటర్ ఫోర్స్ అప్లై చేయాల్సి వస్తుంది అదే ఆబ్జెక్ట్ పైన. అదే 2 ఇక్కడ కాంటాక్ట్ లో ఉన్న సర్ఫేసెస్ ఏంటి, బ్లాక్ ఇంకా కిందనున్న ఈ సర్ఫేస్. ఈ 2 కాంటాక్ట్ సర్ఫేసెస్ కి మనకి గ్రేటర్ ఫోర్స్ అప్లై చేయాల్సి వస్తుంది. But let's talk about an example that the block is already moving, and then we're trying to increase or decrease its velocity. Uh, we are not changing the state of motion, but we're changing what? So it's the perfect exact kind of state of motion change and try it. Like it's moving, it's again moving, but we're trying to make it small change in its state of motion, which is, but in this case we are trying to make a big change, like we're trying to change the state of motion. This might give you a small indication why which coefficient will be bigger and which will be smaller. Anyways, mu static is always greater than or equal to mu kinetic. And friction acting on an object is directly proportional to the normal force acting on the object from the surface. So frictional force is mu into n. Let's say the object is in rest. This will be mu s. If an object is moving with some velocity v, this coefficient will be mu k. These are the uses of static coefficient of friction and kinetic coefficient of friction. And friction acts if and only if there is relative motion between the two surfaces. The object should be sliding over the first surface, which is the surface of the object, should be sliding over the second surface. Only in this case the friction acts. Or we can talk about something like an object is inside a car and the car is moving. We feel that both the surfaces are in motion and friction should act. But no, friction acts when there is only a relative motion between the two surfaces. Here the block is also moving with v meter per second. Surface is also moving with v meter per second. There is no relative motion between the two surfaces. There is no relative motion between the two surfaces. So there is no chance of a friction acting. Let's do a numerical on this. Determine the maximum acceleration of a train in which a box is lying on its floor will remain stationary given coefficient of static friction between the box and the train's floor is 0.15. Okay, we'll try to solve this in the train's frame of reference. There is a train and there is a block on it, and the coefficient of static friction mu is given as 0.15. Maximum acceleration of the train in which the box should be still at rest with respect to train. Let's say the acceleration of the train is u, and we try to solve it in the train's frame of reference. So there is an opposite acceleration of the same magnitude for the object. Now coming to this, object has a net acceleration in this direction, and we want to keep the object at rest. And static friction self-adjusts. If you try to apply static friction is like the maximum value of a friction that can act, mu s into n. Let's say the static friction's value is 10 newtons on this object. And one more thing, friction, I can't say like exactly this way, but friction will okay, let's talk like this. Static friction will never be the driving force of an object. Okay. Static friction will never move an object. It will just try to stop the motion of an object. And let's say the static friction is 10 newtons and you apply 1 newton. The friction force will be acting as 1 newton, but not like friction is 10 newtons this direction. This is 1 newton. You try to pull it in this direction, and friction is pulling in this side with 10 newton force. This never happens. Until a certain limit, that is the maximum static friction that it can hold, it always self-adjusts with an acting force. Like నువ్వు ఎంత అప్లై చేస్తే అది అంతతో ఆగిపోద్ది. అదేం నీకు నువ్వు 1 న్యూటన్ తో పుల్ చేస్తున్నందుకు అది 10 న్యూటన్స్ తీసుకొచ్చి అది ఎక్కువ వెలాసిటీతో లాగేయడం అలా జరగదు. లైక్ ఎప్పుడు జరగలేదు. ఇప్పుడు నువ్వు ఒక ఆబ్జెక్ట్ ఉంది, నువ్వు దాన్ని లాగలేకపోతున్నావు అంటే ఏంటి, ఆ 10 న్యూటన్స్ దాటి నువ్వు దానిపైన ఫోర్స్ పెట్టలేదు, అందుకే అది కదలట్లేదు. ఎప్పుడు ఇలా జరగలేదు కదా. నీకు 10 న్యూటన్స్ ఫోర్స్ కావాలి ఆ ఆబ్జెక్ట్ ని కదపడానికి, బట్ యూ పుల్డ్ ఇట్ 2 న్యూటన్స్ ఫోర్స్ అండ్ ఇట్ స్టార్టెడ్ మూవింగ్ ఇన్ ద రివర్స్ డైరెక్షన్. It never happens, right? So up to a certain point, static friction does not allow the object to move. Okay. At this point, object is trying to move in this direction. So obviously the friction will act on the object in this direction. Friction always acts to oppose the relative motion between the two surfaces. So with respect to the surface, it is trying to move in this direction. So friction will act on the object in this direction. And mm, he asked the box to remain static with respect to the floor. So we want to make the net acceleration of this to be zero. So friction should be equal to mass into acceleration. What would be the maximum friction that could be acting? That is mu static into normal. That is, this is normal, and this is the weight acting on the object. So n equal to mg for vertical equilibrium. Since the object is not flying here and there, mu s into n, that is mu s into mg. So mass into acceleration will be equal to mu s into mg, and one cancels out. Acceleration equal to mu s into g. So the maximum acceleration of the train can be mu s into g. Maximum acceleration of the train can be mu s into g, which is mu s is 0.15 and g is 10, 1.5 meter per second square. This one. Okay, this is how we solve problems on this. And rolling friction. Rolling friction happen. The three types of frictions happen like this. When an object is at rest with respect to a surface, static friction holds, like the static friction acts when we try to apply force first. Then when we try to slide an object on over the other, the sliding or kinetic friction acts. And when we try to roll an object on a surface, like roll it, even then the friction acts, and this type of frictions are called rolling frictions. These are very common in our daily life uses, like there will be ball bearings inside your cycle. The ball bearings and okay. Rolling motion, it will become more clear when we try to solve some problems on it. Like there will be nothing much to speak in it. The three types of frictions and the types of actions. One acts when the object is at rest with respect to a surface. The sliding acts when we are trying to slide an object over the surface, and the rolling friction acts when we try to roll the object over the surface. And the sliding friction is also called as the kinetic friction, which makes the coefficient being called as kinetic coefficient of friction, kinetic friction coefficient. And one more type of motion is circular motion. There are two types of motions. One is called linear motion, in which the object moves in straight lines. There are a whole lot of chapter we discussed. The complete of kinematics will be object moving on a straight line, object moving in square paths and all. And then there are curved paths. And the basic of all curves is a circle. And here we talk about circular motion. As I said, for an object to be moving in circular motion and at a distance r from a center, and it is moving, for an object to be moving consistently on this circle without falling inside. So when we are trying to move on this, what is the driving force that makes it? Let's say an object moved from here to here, velocity moves like this. So something is trying to change the velocity, which is like this to like this. So there is some force acting on it. What force is responsible? Let's say this is happening in a zero gravity region and on a horizontal floor or something. So there should be some driving force which is making this happen. So let's say the velocity is changing this way. And so the change in velocity will be in this direction. This and this. The change in velocity will be okay. This direction. So an object moves in circular motion with a uniform velocity v at a radius r, if and only if there is an attraction force or a force that is being a force that pulls it towards the center with a velocity of v square by r in a direction perpendicular to its velocity. An object in circular motion, let's say the object is here, it is moving with a velocity v in this direction, then the force mv square bar acts in this direction to change its velocity. This is the basic principle of circular motion. For any object to be in circular motion, this condition should be held true, and depending on the frame of reference, the force that is responsible for the circular motion is called either centripetal force or centrifugal force. Centripetal force. This is in the normal frame of reference. Like you are watching from an inertial frame of reference, and the object is moving in circular motion. It is a real force. Centripetal force is a real force. And centrifugal, it is a pseudo force. We try to watch this from a circular reference, like an object. We are in this point, and now we want to see the frame of reference, like motion of this object. So centrifugal force, centripetal force is a real force, and from the ground frame of reference, we'll see the force to be in this direction. But from an accelerating frame, which is accelerating in the same circle, we in the same object, we see that the object is not falling inside. So there must be some force acting in this direction. Based on this intuition, and the acceleration should be same, obviously, since the net acceleration is zero of the object. So the magnitude of centripetal is equal to the magnitude of centrifugal, and don't get confused, they will never act in the same frame. Like you either consider centripetal and do it in the inertial frame of reference, or consider centrifugal and do it in the circular frame of reference, like, or the accelerating frame of reference. Never do both in the same frame. And then you might have seen that turnings on a road. There's a road, and there's some turning like this. You never see the road turnings to be flat and like this. They'll always be banked at a height. So this will be there will be at different heights. Like, let this be the ground. Like, okay, it's not going. Okay, let's say this will be the road. It will always be banked at a height. Why is it necessary? Like, what is the use of it? Whenever we are trying to move on a circular frame of reference, centrifugal force, this tries to pull us away from it. Like, this tries to pull us away from the center. So if you are moving in this type of circle, the center will be somewhere here. If you are coming with a greater velocity, you will get pushed out of this circle. Like, you will try to increase your radius. But then to smoothly complete your circle, you must be moving with a velocity region between this to this. That depends on, that gets devised and formulated using this theta and the friction coefficient and banking. Okay. The motion of a car on a level road, like, there is no acceleration in the vertical direction, normal force and friction. So the only forces acting on it are the gravitational force, the normal force, and the friction force, and the engine's driving force. These are the forces acting. But then in case of circular motion on a banked road, so the road will be something like this, and the car is moving in the circular motion with center somewhere in this line. So okay, here the normal acting, because of the banking, is in this direction, theta. This is the weight. Let's talk about this. Normal. This is the weight mg acting. to support the ball from not falling back, there will be a friction that could be either in this direction or that direction depending on the velocity. And then a centrifugal force. Let's say we're solving this in this, let's solve it in the real frame. Centripetal force. The net acceleration should be in this direction. So the vertical forces should cancel out. Let's say this is theta. This is also theta. But this is theta, 90 minus theta. So this is theta. Okay. 90 theta. Okay, theta. So m cos theta equal to mg plus friction. Does friction have a vertical component? Okay. M cos theta equal to the vertical components of weight mg plus friction mu s and sin theta. Friction, let's say f. This is theta, then this becomes 90 minus theta. So the vertical component will be f cos 90 minus theta. That is f sin theta. F sin theta is nothing but this. So for the car to not overturn and have equilibrium in the y direction, the net forces in y direction should be 0. And this equation says that. And in the horizontal direction, we know the net acceleration should be v square by r. And the horizontal forces are, this is the normal force, weight acting, and this is the friction. And weight, friction. So this is 90 minus theta. This is theta. So v square by r equal to friction f cos theta plus n 90 minus n sin theta. N sin theta plus friction cos theta. That defines normal force to be mg by and from these two equations, if we try to solve for n, we'll get this. And we replace the n value in the second equation. So for an object to not go out from the banking, like the maximum velocity you can come, you can travel on this road such that you do not move out of this road is this. This is generally calculated and put on boards as speed limit of the road, speed limit of the turnings. And this is why indicate cheptaru like turnings దగ్గర కొంచెం మెల్లగా వెళ్ళండి అని. If you go with the same velocity you are moving on a straight line, you will obviously move out of the track. Out of the track in the sense outside the larger radius side, which will obviously result in accidents. And there will be something. If you move with very less velocity, like let's say very less velocity, there is a chance that you might fall inside in the absence of friction. That is because of the angle, tilting angle. That could be solved, and we'll meet such questions. We'll solve some such questions and exercise on such problems, and we'll try to solve a problem on this. A cyclist speeding at 18 km/h on a level road takes a sharp circular turn of radius 3 meters without reducing the speed. The coefficient of static friction within the direction. This is on a level road. Level road, cyclic cut, radius 3 meters. The coefficient of static friction is 0.1. Will the cyclist slip while taking the turn? And he is moving with a velocity 18 km/h. Okay. He is moving with a velocity of 18 km/h. Okay. Now let's talk about the cycler. His weight is acting downward. Normal is acting in the horizontal direction. And there is friction like this. In the cycle's frame of reference, there will be a centripetal force mv square by r. But in his frame of reference, it should be at rest. Like that is when he will be safe. So n equal to mg, and if and only if f is greater than or equal to mv square by r, this holds that it could be in equilibrium. So if f is greater than mv square by r, it self-adjusts to the value the mv square by r is, and then it will be smooth. And friction can be maximum if this friction can be maximum of mu s into m, which is mu s into mg. If we calculate the value, it would be 0.15 into which is 0.1 into 10, 1 Newton. Friction can be maximum of 1 Newton. We use mg. Okay, m newtons. Let's say friction can be mu s mg. That is m at max m, and it should be greater than v square by r. M should be greater than mv square by r. So 1 should be greater than v square by r. V square is 18 kmph, kilometer per hour to meter per second. 18 into 5 by 18, 5 meter per second. 25 by radius square. Radius 3. 8. Is 1 greater than 8? No. So the cyclist will slip while taking the circular. This condition is not obeyed. The condition is not obeyed. So cyclist will slip. There are some rules while solving the equations. Like whenever you try to solve a problem in mechanics, it's always advised to first draw the free body diagram of the object and list all the forces acting on it.
सुशांत,
Yes, sir.
आप जब भी एंड करना चाहो सेशन, then you can.
Okay.
Okay, it's up to you now.
Oh, it's almost completed. Yeah. Whenever we are trying to solve some problems in mechanics, it's always advised to draw the free body diagrams and list all the action reaction pairs in the same vicinity, so we'll never miss while solving them. And in free body diagrams, never use this weights, 10 kgs and all. It will make the image more complicated and difficult to read, and it might sometimes cause errors too. And be sure of the frame you're trying to solve the problem in. Don't mix up. When you're trying to solve a problem in inertial frame of reference, then net acceleration won't be 0. You'll try to equate force equal to some mass into acceleration. But the same problem, when you try to do it in acceleration frame of reference, the net acceleration will be 0. And you try to achieve equilibrium. Like in the pseudo frame of reference, you will always be trying for the equilibrium in that frame of reference. So the calculations will be similar when you try to do it in the normal frame of reference. Like you could practice some free body diagrams, like drawing some free body diagrams, which will help you solve problems. So to briefly summarize, we spoke about this Aristotle's law of fallacy. He told that the force is necessary to keep the body in uniform motion, to which Galileo countered using his smooth floor, the ball thing. And then building upon this Galileo's laws, Newton gave his laws of motion, which are mathematical. The first law of motion states that an object doesn't try to change its state of motion unless an external force acts on it. And the second law states the mathematical way of force, that is the rate of change of momentum. And the third one is more like an observational law, that equal and opposite forces act as action-reaction rates, or to every action there is an equal and opposite reaction. That is the third law of motion. And impulse is just the change in momentum. Impulse is measured as the change of momentum. And when a system is in equilibrium, its total momentum is conserved. That is the law of conservation of momentum. And we talked about friction. So yeah, this will be for today. Thank you guys.